We've been learning about the area model for multiplication. Most of our examples so far have been when we are multiplying a single-digit factor by a two-digit factor. Here's an example that we worked last week where we multiplied 3 times 79. We learned that we had to break apart the number 79 into expanded form, where we're left with 70 plus 9. We then used that to set up an array. Our array had two columns because the number 79 is a two-digit number, and that factor would require two columns in our model. And then we had one row because the factor 3 in our multiplication problem is a single-digit number requiring a single row. Once we set up our multiplication number buddies, we were ready to multiply 70 times 3 to get 210. And then 9 times 3 for a partial product of 27. We took the partial products 210 plus 27. By adding them together, we then got our final product 237. That's a brief review of using area modeling for problems where we have a single digit times a double digit number. Now we're going to learn about how to multiply two double-digit factors. In order to use the area model of multiplication, for an example such as 13 times 26, we first need to consider how we might break apart these numbers. Now that we're dealing with two double-digit numbers, we will have to break apart both factors into expanded form. We would do that starting first with the number 13, as we break it into 10 plus 3, because we have a 1 in the tens place and 3 in the ones, so we're left with 10 plus 3. And then we break apart the number 26 into expanded form by writing 20 plus 6. We had two tens, which equals 20, plus 6 ones, which is 6. Notice that now that we have two numbers that are double digits, our array is going to look different. Now, our array requires two columns as well as two rows. In order to set up our number buddies now, you will notice that we will have 10 and 3 as our two rows, and 20 and 6 as our two columns. Now we're going to have 4 sets of number buddies. Let's start first by multiplying 20 times 10. Anytime we multiply a number by 10, all we have to do for a shortcut is to add 1 0 to the number. Because we know that 2 times 1 is 2, I can then add the 0 from 20 and the 0 from 10 to come up with the answer of 200. Let's now multiply 20 times 3. We know that 2 times 3 equals 6, and I need to add 1 0 to compensate for the 0 in our factor 20. I'm left with 60. 20 times 3 equals 60. Now moving on to our 6th column, we have 2 more number buddies to multiply. Let's start with 6 times 10. Well, if I count up by 10 6 times, 10, 20, 30, 40, 50, 60, I find that 6 times 10 is 60. My last pair of number buddies to multiply is 6 times 3. 6 times 3, if I count up by 6, 3 times, 6, 12, 18, I know that it's 18. Now, I have 4 partial products that I need to combine to find my total product for the problem 13 times 26. My partial products are 200, which I will add to 60, plus 60 plus 18. I notice that I have 62 times, and I know that these two numbers combine to make 120. I'm going to use that to shorten my column addition. Now I'm going to do 200 plus 120 plus 18. When I add these three partial products together, I'm left with a final product of 338. We would say that 13 times 26 equals 338. Let's do one more example. 38 times 56. Again, this is an example where both factors are 2 digits, so I will need to break apart both double-digit factors into expanded form. I'm now left with 30 plus 8 and 50 plus 6 as a means of representing these factors in expanded form. Because both factors are double-digit, I'm going to need 2 rows and 2 columns in my model. Using my expanded form information, I am going to now create my array. The factor 38 was broken up into 30 and 8, so that is how I will label my rows. And the factor 56 was expanded to 50 plus 6, and that's how I will label my columns. I'm now ready to multiply my number buddies. I'll start by multiplying 50 times 30. I know 5 times 3 equals 15, and I need to compensate. I see that there's 1 0 in 30 and 1 0 in 50. I will need to add both zeros to my answer to come up with a final partial product of 1,500. Now I will multiply 50 times 8. I know 5 times 8 is 40, and I need to compensate by adding 1 0 because there's 1 0 in 50 to get the answer 400. Moving on to my next column, I'm going to start by multiplying 6 times 30. I know 6 times 3 is 18, and I will compensate by adding 1 0 because 30 has 1 0 in it. My last set of number buddies is 6 times 8. That's a basic fact that we memorize, and we know that 6 times 8 is 48. Now that I have my partial product set up, I'm ready to show that to find 38 times 56, I will combine all 4 partial products. 1,500 plus 400 plus 180 plus 48 will give me my final answer. To help me organize this information, I am going to set it up as a column addition problem just to give myself more space to work and to keep my places organized. Notice how I'm carefully arranging my ones in a column, my tens in a column, my hundreds, and my thousands. The ones column adds up to 8. 8 plus 4 is 12. I write my 2, carry the 1. 1 plus 5 is 6, plus 4 is 10, plus 1 more is 11, and then 1 plus 1 is 2. The product of 38 times 56 is 2,128. This is our final answer.